Welcome to Brain Vision.
Hi there. So for this problem, we need to calculate the magnetic field at a point P, which is located at this position. And we are given that the current element is this one in here. So to find the magnetic field, we use that the differential magnetic field, the vector of the magnetic field in this case, should be equal to mu sub 0 over 4 times pi. The magnitude of the current, we are also given that value, and it is 5.40 amperes. And so the equation is also the cross product between the current element and the position vector. This over the distance cube. So the first thing that we can determine in this is the distance cube of the that will be that r cube is just the magnitude of the vector r to the cube. So we are going to do that. We know that the magnitude of the vector r is just the square root of the sum of the square of each component. So it will be something like this: 0.73 square plus 0.39 squared. We take the square root of this and we elevate all of this to 3, so that when we put these values into the calculator, we have 0.667 meters cube. So with this, we can just plug all of the information in the differential of the magnetic field, vector of the magnetic field. So we will have mu sub 0 over 4 times pi. We'll have the value for the current, which is and this over the distance cube, which is now in here, I'm gonna put the product between these two vectors, the L and R. So we will have the following: 0.5 millimeters. So that millimeters is 10 to the minus 3 meters. This in the I direction, cross product between 0.73 meters in the I direction, and this is minus plus 0.39 meters in the K direction. So we need to do this cross product. We know that when we do the cross product of the same unit vectors, when we do I cross product with I, we obtain 0. So from there, that term we obtain 0. But from the other one, we will be doing the cross product between I and K. And that cross product, if we know the rules for that, we can see that that will be I times this, and that will give us minus J, because if we do K cross product with I, we'll obtain plus J. So in that sense, we will obtain minus J, this in here. So with that in mind, we can just simplify that as the following: mu sub 0 over 4 times pi over the distance cube, which is 0.5 meters cube. And so from there, as I said, we'll obtain the product between these two. So we will have minus the product between 0.5 times 10 to the minus 3 meters times 0.39 meters. That's the only component that survives after the cross product, and this in the J direction. So with this, we just need to simply put the values of mu sub 0, and the value for mu sub 0 is 4 pi times 10 to the minus 7. So the 4 pi goes away with this, with the 1 in the denominator. So we will obtain 10 to the minus 7. Let me correct that. Okay, and we will have the other terms. So we'll have 5.40 amperes over 0.567 meters squared, meter cube, and we will have that product too. So plugging all of this into the calculator, we obtain a value of minus 1.857 times 10 to the minus 10 Tesla in the J direction. So this is the magnetic field at the point P. So this is it for this problem. Thank you.